So this is 4a from the same exercise, and I've already started this question. So our top term we're going to call u, and then we're going to differentiate that. The bottom term we're just going to call v. Now this we can write as x plus 1 to the power of a half. So when we do our chain rule, we bring the half to the front, write the same thing, decrease the power by 1. Also, it ties by the derivative of what's inside the parentheses for this one, and as this one is just 1, it doesn't actually have any effect. Now, using our quotient rule then, so v du minus u dv all over v squared. What we can say then is that we've got x plus 1 to the half times by du, which is just 1, so that doesn't do anything, minus u times dv, so x times by a half is going to be 1 half x, x plus 1 to the negative half, all over v squared, which is x plus 1 to the half squared. So power to a power rule, you multiply that. Half times 2 is just 1. Or you could just say a radical squared will just give you x plus 1. And then we're going to try and simplify this. Now there is a common factor here. We're going to go with x plus 1 and x plus 1. And I take the one with the lowest power, so negative 1 half here. And then look what I need to do to get this one. So for the first term, if I times by x plus 1 to the power of 1, remember when you multiply, you add the exponents together. So negative 1 half plus 1 would give me the power of 1 half. So I don't really need the 0, so I'm the 1 here, so I'm just going to get rid of that. Minus, and then on this term, this one matches fine, so I'm just missing a half x. All over x plus 1. Now I can also use that rule of exponents again, but this time for division. So when I divide, I'm going to subtract the two exponents. So negative 1 half take away 1 is negative 3 over 2. So as it's negative, I can just bring this to the bottom here and write it as positive 3 over 2. Inside the parentheses, I got x take away a half x, which is a half x, and then plus 1. Now, we don't really like fractions within fractions, so what I can also do is I can take that half out as a factor also. Half times 2 being 1, and a half times x is a half x. All divided by x plus 1 to the 3 over 2. And then one very small change, I can bring the 2 to the bottom here as well. So it would just become x plus 2 over 2 times x plus 1 to the 3 over 2. So that's one good way you could actually answer that question. Now there's another way we can simplify this expression as well. So I don't particularly like the negative exponent for this question, so what I could choose to do is just to multiply each term by x to the power of 1 half. And provided I do this to each term, this is not actually going to change the question. Now the reason I chose x to the power of 1 half is because it's the inverse of negative 1 half. So when I actually multiply these two things together, I'm going to add the exponents together. But negative a half plus 1 half is just going to give me to the 0. And anything to the power of 0 is just 1. So when I come to simplify this, as I'm multiplying here, I'm going to add the exponents together. So that will just become x plus 1 to the power of 1 minus. This comes x plus 1 to the 0, which is why I do it, which is 1. So in other words, I just get left with a half x. And then this one I'm multiplying, so I have the exponents together. And then this should look pretty familiar to what we had before. So x take away a half x is a half x plus 1 over x plus 1 to the 3 over 2. Take a half as a common factor and bring it to the bottom. Then on top what I'm going to have is x plus 2. Because 2 divided by 2 is 1. So same answer, but just a slightly different way of simplifying if you prefer.